And here's the second part of worked example 6. A jet travelling at 450 knots flies westwards from A, 20 degrees north, 138 degrees west, to B, 20 degrees north, 110 degrees east. How long does it take? Okay, so we're going to be looking for time. Okay, we've got some information about speed. All right, maybe we'll start with the information about the location. So it's going to be travelling westwards from A, 20 degrees north, okay, to B, 20 degrees north. So we know that we're travelling on a line of latitude, a parallel of latitude, okay. So we could say, here we go, this is at 20 degrees north, okay. We've got some information that this one's 138 degrees west, so it's 138 degrees there. Oops, apologies, there. And this one is 110 degrees east, so 110 degrees east. All right, so whenever we have a problem with latitude, it's best to draw a plan view, make sense of it a little bit more. So here we go. Here we go. Here is the meridian, prime meridian at 0 degrees. Okay, point A was at 138 degrees. Point B was at 110 degrees. And this was west. So for some people, you might like to just draw those arrows in because it might help you. Now, the jet was travelling from A westwards, so it's going to continue around in this direction. Okay, so what we're looking for, we're going to need to know this angle here. All right, so maybe let's start with that. The angle is going to be equal to 360 degrees. Take away these two angles, 138 plus 110. So 360 take 248, which is 112 degrees. So it's travelling 112 degrees. We're on a line of parallel of latitude, so we're going to have to use our distance formula. That's slightly different. Now we're thinking, oh, the question's asking me, has a question about knots. So knots links to nautical miles. So I need distance in nautical miles. So I have to use distance is 60. It's a parallel of latitude, so I'm going to use the cos alpha version times by my angle. So we've got 60 cos. Okay, what was alpha? Alpha is the line of latitude, 20 degrees. Theta, what's theta? Theta is this. Theta is the distance, sorry, the angular distance that I've travelled. So we've just said that's 112 degrees. So plonk that in your calculator. Plonk, 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 plonk. And you should get 2,741.31. Now we're measuring distance in nautical miles. So we've got a distance. All right. What do I need? The question says, how long does it take? So I want time. I've got speed, I want time, I've got distance. Okay, so what do I know? We know that speed is equal to distance over time. I think you've learnt that in Year 10 Science, hopefully, or hopefully you kind of understand the concept. If I want to get time on its own, I need to rearrange the formula. Some of you might be taught a few shortcuts, okay? But basically, if you were to do it slowly, I'd multiply both sides by t to get t up the top. Then I want t on its own, so I divide both sides by s. I get time is equal to distance over speed. Kind of makes sense. How far did I travel divided by how fast I was travelling, okay? So distance, we travelled 2,741 point. Now, you should have that continued answer in your calculator. And I'm going to encourage you to use the whole thing. So here I'm going to indicate that by dot, 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 okay? Divided by my speed, which is 450. And I should get something along the lines of 6.094 hours, okay, because speed, knots, was nautical miles per hour. Now, generally, we don't like doing this sort of thing. It's better to figure out this bit in minutes. So that's 6 hours. To figure out what 0.94 hours is in minutes, we just do a little calculation. You don't even really need to show it. Just do it times 60, and you're going to get an answer that says 5.6. That's saying 5.64 minutes, okay? So let's round that up to a whole minute. 6 hours, 6 minutes. So Worded question, worded answer. Therefore, the jet takes 6 hours and 6 minutes to travel